Another method is called the pitot tube method. Works very similarly to this style of Venturi. And it shows in the textbook. There is a graphic display of how that works as well. Not very popular. It works off of a pressure differential. A pitot tube is, we use the pitot tube to measure pressure in a sprinkler nozzle. That little tube we stuck into that nozzle of the sprinkler. See, we get the full center pressure lined right in the middle of the pipe. With that pitot tube, that's what we do. We put a pitot tube right into the center of the delivery pipe and run a tube into our chemical tank and back out and let it force it out the downstream side. Use the same basic concept. Again, you have the dilution problem. As this thing works, it dilutes. So this chemical in this tank starts off at one ratio of mixture, and it just gets more diluted, more diluted, more diluted. And if you're just watering a block, that's okay, but if you have a continuous move system, a center pivot, a traveler, you know, those big gun travelers, it's not going to work at all for those. Or if you have rapid change, golf course, 5 minutes to 5 minutes to 5 minutes to 5 minutes, you know, by the time you get to the second hour of the cycle, you've got way different chemical concentration you did at the beginning of the cycle. The next is pressure injection pumps. And that's what the world has come to in most of these applications. We can use injection pumps to meter in the chemical as we want it. And the two styles that are most popular are piston and diaphragm pumps. Got the piston pump and the diaphragm pump. Now all we're doing with both of these is we're simply vacuating a chamber. Every stroke of the piston, on the outstroke the chamber fills, on the instroke it purges the chamber. Out fills, instroke purges. And so we know that every stroke of the pump is going to push an exact amount of liquid downstream through the system. And all we have to do to change the flow rate is change the length of stroke of the piston. We can make this, if we want more liquid going, we make a longer stroke. So we have a longer cylinder, we're filling a bigger cavity on every stroke of the piston. If we want less flow, we shorten the length of the stroke of the piston. So we just put it on a cam. We hook the piston drive to a cam, and we can adjust the position on the cam that we put the piston rod, so that it can be as short or it can be long. And they'll set the RPM. We know how many revolutions per minute. That's how many strokes a minute we have. And we know exactly how big the chamber is. We can calculate exactly how many ounces a minute we're going to be injecting into the system. And then you have to know by your calculations of the chemical you want to apply as to how fast you want to inject it. Now we have a piston pump and a diaphragm pump set up over here on the floor. They're not very big. 1/3 of a horsepower, 1/2 of a horsepower is all sometimes 1/4 of a horsepower is all that we need. We don't need a lot of horsepower. Now a piston pump or diaphragm, they're extremely high pressure potential. They just keep building more pressure and more pressure and more pressure. So they're always going to have a greater pressure capability than whatever the water supply has. So these are a very direct and very accurate way to proportion a chemical into a water supply, because it will always win the battle of the pressure. It will build pressure as you make it build pressure. And it'll overcome any pressure of any of the systems that you're going to operate. Very high pressure and extremely constant rate of application. And so we have our tank sitting isolated, and we're simply feeding water through the piston pump into injecting it right into the water supply.